CryptoLocker is ransomware that first appeared in September 2013 and has been spreading wildly in Europe and the USA in early 2014. It spreads mainly by employing a method called phishing, where users are tricked into opening an email attachment, although other common infection methods are also seen. When CryptoLocker infects a computer, it encrypts the user's data files on the local drive and on the network, rendering them unusable, creating mayhem to corporations where data and backups are stored on file servers. It then demands that its victims pay a ransom of €300 or $300 to decrypt and recover the files. CryptoLocker uses RSA 2048-bit encryption, making it undefeatable without the decryption key. The criminals who produce the virus do, however, honour their word to decrypt the files when a ransom payment is made, and as a result, many victims have paid the ransom to get their files back. A survey by researchers at the University of Kent found that 41% of CryptoLocker victims in the UK have admitted to paying the ransom. It is estimated that the CryptoLocker criminals made $30 million ransom money in just 100 days. In this demonstration, we show how HDF blocks CryptoLocker's infection attempt, and then we'll show what CryptoLocker does without HDF protection. The version of CryptoLocker in our demo has the randomized file name ZKA-UHX-FB-MPUBHR. Firstly, we place the CryptoLocker executable file on the network drive, and shortly we will simulate a CryptoLocker infection by running the executable, as if a user is tricked into opening an attachment from a phishing email. Currently, HDF is turned on and in protection mode, blocking unwanted write operations to the disk. Now we will run CryptoLocker. As soon as we do so, we can see that Process Explorer shows that CryptoLocker starts, as indicated by the green bar, and then terminates almost immediately, as indicated by the red bar. When we examine the HDF log file, we can see that HDF blocks CryptoLocker's attempts to infect the computer. HDF audits exactly where CryptoLocker attempts to infect the computer, and we can check to confirm HDF has prevented the infection. The code 1 in this column shows HDF has stopped CryptoLocker writing itself to the computer. We can now double check the CryptoLocker executable file is indeed not on the computer, using both the File Explorer and a command line directory listing command. As we can see, it isn't there. HDF has successfully blocked CryptoLocker from infecting this system. Now, to allow CryptoLocker to infect the computer, we will turn off HDF protection using the menu. The blinking X at the bottom right of the screen reminds the user and us that HDF is turned off. We have prepared some Word documents for use in this demonstration, which we'll take a look inside of. One is on the desktop of the local drive, and another is on a shared network drive. We can see that they are normal Word documents. Now we will run CryptoLocker. CryptoLocker only reveals its graphical interface after it has encrypted the victim's files and safely stored the decryption key on a remote server. This makes sure the victim has little chance to interrupt and recover from the CryptoLocker encryption process. The red dialog details the ransom demand and threatens that the user files will be unrecoverable after 72 hours. It even includes a clock counting down from 72 hours, making good use of visual effects to scare the victim. And now, when we open data files on the network, we can see that they are encrypted. So we know CryptoLocker's red dialog only displays after it encrypts the victim's files, and the decryption key is safely stored on the remote server. It also changes the user's wallpaper to one of its own, which appears behind the threatening user interface. The wallpaper instructs the user on how to reinfect the computer with CryptoLocker if an antivirus program has deleted the CryptoLocker file. This is because the victim needs the CryptoLocker executable to decrypt the lost files after having paid the ransom money. It also warns the victim exactly when their files will be lost if they don't pay, in an attempt to scare them. The criminals don't worry about being detected and removed. It arrogantly says if the victims don't pay, they can just remove the CryptoLocker wallpaper, along with all their unrecoverable data files. If the victim is prepared to pay, then he or she can follow the instructions to buy bitcoins using euro or US dollars for payment. CryptoLocker even includes links to the Bitcoin homepage and getting started instructions on how to pay, for those victims who are unfamiliar with Bitcoin. When the ransom is paid, the victim's files are recovered, and the red dialog will turn into a green one, but since we didn't pay the ransom, that is not shown here. CryptoLocker has simple, basic protection for its process. When the CryptoLocker process is terminated, it resurrects automatically. We can see using Task Manager that the CryptoLocker process returns immediately after termination. CryptoLocker is a particularly vicious virus. It represents a worrying shift in tactics employed by cybercriminals who are now using sophisticated software engineering techniques to create ransomware designed to extort money from innocent users. HDF helps protect against such techniques, preventing the malicious code from ever being written to the local drive. For more information on HDF, please visit www.abatis-hdf.com.